All right, welcome. In this video, I'm going to be working Algebra 2 Quiz 6.1, which is over polynomial functions. Okay, so there's going to be some solving equations and I think identifying some pretty basic aspects of polynomial graphs. So the first one is, hey, solve this equation, show the work that leads to your answer. So really our only hope for these ones that are higher than degree 2 is to set them equal to 0 and factor. Because we're not going to be using the cubic formula, we're not going to be using the quartic formula, none of that stuff. We're just going to be using factoring. And so what we're going to do, we'll start by subtracting 7x squared from both sides. So x to the 3 minus 7x to the 2 plus 12x equals 0. And now I'm ready to factor. I think about, is there a greatest common factor? There is. I can pull out an x. Okay, and now I need to think, is the thing in parentheses factorable? Can I think of two numbers that multiply to 12 while adding to negative 7? Yes, I can, negative 4 and negative 3. So x times x minus 4 times x minus 3 will equal 0. And so that means that either x is equal to 0, or x minus 4 is equal to 0, or x minus 3 is equal to 0, giving me solutions of x equals 0, x equals 4, and x equals 3. Okay. What is the y-intercept on the graph of p? Okay, well, the y-intercept of any function is just the value of that function when you plug in x equals 0. So I'm going to say p of 0 is equal to 0 to the 4, minus 5 times 0 to the 3, that'll just be 0, minus 6 times 0 to the 2, plus 7 times 0 minus 8, which is equal to negative 8, and that's why that constant term represents the y-intercept, right? At least on a polynomial. What is the leading coefficient of f of x? Okay, leading coefficient is the number that's attached to the highest power of x. Okay, so I see x to the 5 is the highest power. Okay, the number that's attached to that is 1/5. It doesn't matter if that's the first term you see in the polynomial. Had this been negative 3 minus 2x plus 1/5 x to the 5th, the leading coefficient would still be 1/5. Okay, it's the number that's attached to the highest power. Okay, and then the degree of a polynomial is that highest power itself. Okay, so this is not like a degree 0 because there's no x attached to that 1. It's the first thing I see. It's degree 3 because 3 is the largest exponent. All right, now we're going to write a standard form polynomial that could describe the graph pictured here. Okay, so we don't have any scale in the y direction, so we're not going to have to worry about, what the leading coefficient is. So maybe I'll just assume the leading coefficient is 1. So what we're going to do here is we're going to start off kind of with a skeleton. We start off with our zeros. We've got x equals negative 2, x equals 0, and x equals 3. And we learned in the last unit the connection between zeros of a polynomial and factors of the polynomial. So that means that if x equals negative 2 is a 0, then x plus 2 is a factor of the polynomial. And if x equals 0 is a factor, or is a 0 of the polynomial, then x minus 0 is a factor. And if x equals 3 is a 0, then x minus 3 is a factor. Okay, and what we do, eventually I think we're going to solve for the leading coefficient, but that a is going to be the leading coefficient. Now, for us, it can be anything we want. You can choose any number. It just needs to be positive, right, because of the end behavior. So I'm just going to choose positive 1, and I'm going to say y equals x minus 0. We can just write that as x plus 2 times x minus 3. And I'm realizing now they said standard form, so I'm going to need to do a little bit more work. I thought I was done. Okay, so I'm going to move that up there and say, all right. I think what I'm going to do is I'm going to multiply out the x plus 2 times x minus 3, and then I'll distribute in the x after the fact. So that's x times, all right, I know I'll have an x squared. I'm just going to kind of unfactor these things, right? We know that when we factor, the middle term is kind of the sum of the two numbers, so 2 plus negative 3 is negative 1x. Then that last number is the product of the two numbers that you factor on, so 2 times negative 3 is negative 6. And then x times x squared is x to the 3. I'm just distributing in this x minus x to the 2 minus 6x. That's equal to y, and that's going to be my standard form polynomial. Okay, now we're back to solving. We'll do a little bit of solving and then a little more sketching. Okay, so solve the equation, show the work that leads to your answer. All right, well, this thing is already set to 0, so my job now is to just factor. So I can do that. I think if I've got 4 terms, I'm hoping I'm going to be able to group and factor. I see a greatest common factor, so I think I'll do that first. Factor out that x, and then I'll have x to the 3 plus 5x to the 2 minus 4x minus 20. That does have, looks like it's got the parallelism we need to do group and factor, because the ratio of 1 to 5 is the same as the ratio of -4 to -20. So I'm going to think, what can I factor out of the first 2 terms? Just an x squared. And I'd be left with an x plus 5. And then out of the second 2 terms, I can factor out that -4. I'll be left with an x plus 5. It's a good sign. So then I factor out the x plus 5. And then I'm left with x squared minus 4. Okay. Now, if your goal is to just factor this thing down all the way, or you love difference of 2 squares, then you could factor x squared minus 4 also. But I think I'm going to actually stop my factoring here, because I could say, each of these factors I can solve. So x equals 0, that's already solved. X plus 5 equals 0. That would give me x equaling -5. And x squared minus 4 equals 0, well, that would give me x squared equals 4, and I could take the square root of both sides. And I just have to remember to, bring in that plus or minus, right? Because there's 2 numbers that if I square them, I can get 4, and that'd be 2 and -2. So, and what I'm thinking is that since this is looking a little crowded, I'm going to display my solution off to the side. So x equals 2, x equals 0, x equals -5, x equals 2, and x equals -2. Now we're going to sketch a graph. Okay, so the steps here is first identify the degree and the leading coefficient, then factor, label the zeros, and then try to, make everything fit with the end behavior. So I'm over here and I'm thinking, oh yeah, first, degree and leading coefficient. The degree is the largest exponent I'm seeing. So this is degree 3. Leading coefficient is the number that's attached to that highest exponent term. That'd just be 1, because I just have 1 x to the 3. Okay, so the end behavior of an odd degree polynomial with a positive leading coefficient is going to be, okay, as I move to the right, it goes up, and as I move to the left, it goes down. Okay, it looks like overall the graph of y equals x cubed. So I think, and then now I'm going to factor on this thing. So I'm going to factor out the x times x squared minus 25. Which, this time maybe I'll take it a little bit farther. X plus 5 times x minus 5. So my zeros are going to be at x equals 0, x equals -5, and x equals +5. Okay, so I, kind of draw in an x-axis, label my intercepts. Okay, kind of start with the end behavior. Right, that it's essentially going up on the right and down on the left. And then we just kind of fill in. And for today's lesson, all of these zeros, we're going to go straight through. And then, we'll see, or maybe you've already seen later in the unit that that's not always the case, but for this one today, I only ever gave you the types of polynomials where the zeros were, the type of zeros where the graph is just passing through. Okay, so that's going to be a sketch of the graph. Oh, label the x and y intercepts. Pardon me, forgot to do that. That won't be too hard because we just bring in a y-axis where x is equal to 0. And there I have labeled the x and y intercepts. Now this last one, we're going to sketch the graph of the polynomial function and do the exact same thing. But fortunately for us, it's already factored. So what I need to point out is that this is going to be a fourth degree polynomial, because if I multiplied all of this stuff out, the highest power of x I would see is 4. Okay, and I also can know that because I can count, I've got these 4 factors, each with 1 power of x. That's going to be a total of 4 powers of x. So this is degree 4. The leading coefficient is going to be 2 if I multiply that all out. And if you're unable to see why that's the case, maybe you should come talk to me, like before class or something. I'd be happy to show you like why I can tell that the leading coefficient is going to be 2. it's definitely going to be positive. If the leading coefficient is negative, you're going to see some sort of like negative number on the outside multiplied, or maybe like a 3 minus x, or like a negative x somewhere. But we're not seeing that. So it's going to be an even degree polynomial with a positive leading coefficient, which means that its end behavior is going to look like the end behavior of y equals x squared. Okay, so even degree, positive leading coefficient. I have to label my zeros now. So 2x could equal 0 when x equals 0. Okay, 2 never equals 0, so 2 is not contributing any zeros to this polynomial. Okay, x minus 1 could equal 0 when x equaled 1. X minus 3 could equal 0 when x equaled 3, and x minus 5 could equal 0 when x equaled 5. Okay. So I can label my zeros 0, 1, 3, and 5. And I kind of start with the end behavior. I'm just going to kind of pass through these zeros, and there I've got myself a sketch of the graph of this polynomial. All right, that was good. All right, now let's work problem B. I'm going to go a little bit faster on this one. So solving these equations, we got to start by setting them to 0. Okay. And then I factor. So factor out an x, because that's the greatest common factor. Then I'm hoping that what's in the parentheses is factorable, but it's not a huge deal, because if it's not, I could always use the quadratic formula. Thinking two numbers that multiply to 30 and add to negative 11, negative 6 and negative 5. So okay, and then I think about, okay, x could equal 0. That would cause the equation to be true. X could equal 6, making x minus 6 equal to 0, making the whole equation true. Or maybe x could equal 5, which would make x minus 5 equal to 0, thereby making the equation true. Okay, so these are going to be my values of x that make the equation true. Okay. What's the leading coefficient of p? Well, it's going to be the number that's attached to the highest exponent. That's the highest exponent. I see 1 x to the fourth, so the leading coefficient is 1. Okay, the degree of f is that highest exponent, so that's going to be 5. And then the y-intercept of g is going to be given by g of 0. It's the y-coordinate of the point on the graph where x is equal to 0. So g of 0 is going to equal 5 plus 4 times 0 plus 3 times 0 plus... Wait. 3 times 0 is not 3. Plus 2 times 0. And then in total, that's going to be 5, and so that's the y-intercept. Right. Now, we're going to write a standard form polynomial for this graph. And so really, we're kind of just looking at the zeros, connecting those to factors, x minus negative 3, x minus 0, and x minus 4. Okay, well, I'm going to rewrite that. I'm going to say, really, it's probably going to be some number. It could be, we don't have any scale in y, so it could be some sort of, multiplier, some sort of leading coefficient. And it's probably going to be an equation y equals a times that. I'm going to take that x minus 0 and just write that as x. And then take x plus 3 and x minus 4. Now I'm going to multiply x plus 3 and x minus 4 first. And I'm also just going to say, since I don't have any reason to believe it's not, I know the leading coefficient needs to be positive looking at the end behavior of this thing, because it's going up on the right and down on the left. So if it can be any positive number, I'm just going to choose 1. So I'm going to distribute x plus 3 times x minus 4. And then I'm going to multiply in that x. And then that will give me a standard form polynomial. So it'll be x to the 3 minus x to the 2 minus 12x. And that could represent the graph over there. Okay. Now we're going to solve this equation. And so I'm seeing 4 terms, so I'm thinking to myself, hopefully we can do group and factor on this. And there is a greatest common factor, there's x, so I'm going to start with that. Wait, 22 2x to the 2, negative 25x to the 1, and negative 50. And then I can group and factor. I'm going to factor out x squared and get x plus 2. I'll subtract 25. I'll be left with x plus 2. And so x times, I factor out the x plus 2, and then I'm left with x squared minus 25. And so either x is equal to 0 or x plus 2 equals 0, which would give me x equals negative 2, or x squared minus 25 is equal to 0, which is where x squared equals 25, and x is equal to plus or minus 5. So in total, to give whoever's grading my quiz a really good chance of seeing my answer and all of my answers and not just missing something, I'm going to go off to the side and I'm going to list my solutions. X equals 0, x equals negative 2, x equals positive 5, and x equals negative 5. Right. And these last two, we're just going to be sketching some graphs. Okay. So it starts with identify the degree and the leading coefficient. So we'll be able to do that. So I'm going to say, all right, degree is going to be 3. The leading coefficient is going to be 1. So this is an odd degree with a positive leading coefficient. It's going to look, at least in terms of its end behavior, like y equals positive x cubed. I need to factor this. Yeah, I see that this polynomial is going to have zeros at x equals 0, x equals 4, and x equals negative 4. So I'm going to draw myself an x-axis, label my zeros. So negative 4, 0, and 4. You kind of start with the end behavior. Okay, I know that on the left, this graph is going down. On the right, it's going up. Okay, and then from there, we're kind of just connecting this stuff, passing through all of these zeros, making sure we're hitting all of these points and fitting into the end behavior. And so we've got ourselves a sketch. Right, we can draw the y-axis to label our y-intercept. I feel like I'm remembering, I don't know that I labeled the y-intercept on the last problem on Form A. Let me go back and look. What a shame. I definitely did not. I mean, I guess you might say it's kind of labeled because, it's got a point on it. I'm just going to draw in that y-axis to make this look, as good as possible. Okay, and there we go. Now let's go back to the problem we were currently working on. Yes, okay, back to this one. So the last one, I'm seeing 4 total powers of x, degree 4, positive leading coefficient, because I've got 3 times x, not negative x. I don't have any, I don't have 2 minus x, or negative x plus 4, or something like that. So I've got a even degree, positive leading coefficient, looks more or less, at least on the outsides, like the graph of y equals x squared. Okay, so I label my zeros. 3x equals 0, that gives me x equals 0. This will give me x equals negative 2. Over here, x equals negative 4. And then lastly, x equaling negative 6. So I make myself an x-axis, negative 6, negative 4, negative 2, and 0. So it's got to have this type of end behavior. And so I'm going to just kind of start from this one and hope that it fits. If you are, sketching your graph, and you start with the end behavior, but you're not able to make that graph fit that, and that's probably a bad sign. Something's gone wrong along the way, so you can double check your work. Okay. But that's going to be all for this quiz. Thanks for watching. Hope it helped.